In this video, we will use GSAP and JavaScript to move this satellite and make it follow the position of our mouse cursor. So I have created this scene and I will move this satellite here according to the position of my mouse on the screen. So how do we get that position? Well, first off, I'm gonna just create a new trigger, an execute JavaScript trigger when the timeline starts on the slide. Click OK, and here's what we're gonna put in here. I'm gonna move on to my code editor here. And basically what I wanna do is add a event listener. So document dot add event listener, open and close some parentheses. And in here, we're gonna just enter a single set of quotes and type mouse move. You can see that there are a lot of different events we can choose from. We're gonna just put in mouse move. And then we're gonna add a comma and type function, parentheses, event, and a squiggly bracket. So what we need to do now is create a variable called mouseX, which will allow us to get the position of the mouse on the x-axis, so on the horizontal axis. Is going to equal event.clientX. Now, if you want more details about the mouse event, the move mouse event, you can find them in any JavaScript documentation. I'm using here the Mozilla documentation. So this is all explained here. And we're going to do the same for the Y. So mouse Y equals event.client Y. So what does this do? This will add an event listener to our document, which will be our exported project. So think of it kind of like a web page. It will add an event listener. And this event will run this function each time the mouse moves. So each time the mouse moves, we have a set of variables which take on the position of the mouse on the x-axis and the position of the mouse on the y-axis. And we're gonna just type in a console log, so console.log, and we're gonna log the position of our mouse just so we can see if this works. So gonna enter a set of quotes, so mouse x equals, I'm just gonna press a space, comma, mouse x, then another comma, mouse y. And we're ready to paste this in our trigger. Now this will initialize when the timeline starts. It will begin to listen. It's okay if we just set it up when the timeline starts. Let's publish and see what we have. So if I publish now and move my mouse around, you can see that nothing happens on the screen. But if I click here, right click and inspect, so I clicked on the edges of our slide, I can see here in the developer tab that if I move the mouse around, this value updates for the mouse X and the mouse Y. So this is the position of the mouse in my web page here, on the menu, on the slide. Good, so we know it works. Let's just visualize this in Storyline as well. So I'm gonna create two variables here. I'm gonna create first a number variable called SL_mouse_X. Set it to number, and I'm gonna duplicate it and call it SL_mouse_Y. And in the JavaScript trigger, before the console log or after, I'm gonna click before the event listener and get our player. So var player equals get player. We are doing this outside the event listener because we need to only run this once to get a reference to the player. So now that we have our player, I can go ahead and type player.set var to set our SL mouse X variable to mouse X. And do the same for the Y. So player set var SL mouse Y to mouse Y. Copy all of this, paste it back here, and I'm just gonna insert a text box here. so we can see the variable. So let me type in a white color. I'm just going to make it bold so we can see it easier. So mouse X and mouse Y. And here I'm going to insert a reference to mouse X and mouse Y below it. Let's also center this. So now if I publish, you can see that the values update each time I move my mouse around. This is just what we wanted. They update in the console as well. So if you don't want that, we can just remove this line here because we don't need it anymore because we know it works. Good. Now let's tie this into our satellite here. First off, I'm gonna give it an accessibility name of satellite. So I can just select it with GSAP and move on to my JavaScript right here. And I'm gonna type in document. First off, I'm gonna set a variable of satellite equals document dot query selector data dash acc dash text equals single set of quotes satellite. Close the bracket here and semicolon. So what this does is search the document, which is our project, for an element that has the data accessibility text property of satellite. And this will allow us to store this reference in our satellite variable right here. And then we will be able to move it with GSAP. Now, if you need more details on this, I have a video on GSAP on this channel, which you can watch. So we're going to select the satellite, comma, quickly brackets, and we're going to move it to an X of mouse X and a Y of mouse Y. So we're going to move them to these updated positions each time the mouse moves. You can also use the gsap.set method here to move it instantly, to teleport it basically to the new position. I'm just going to use 2 for a more fluid animation. So I've copied this into my JavaScript trigger. So if I publish now, you will see that if I move my mouse, the satellite moves as well. But the satellite is not in the exact position as my mouse cursor, as you can see here, even though it mirrors its movement. So if I move the mouse right here, the satellite will move as well. What if we wanted to only move when we're within the bounds of this slide? So you can see the mouse X here is also, here is the mouse X of 0. We want this one to be, so we want 0 to be here on the X-axis. And for the Y as well, we want it to be in this corner. So how do we do that? Well, the first thing we need to do is check if the mouse coordinates are within the rectangle bounds. I'm just going to right click here and inspect and see if our slider element has a name. So after clicking on this arrow and opening a few of them, I can see that the div ID of the slide is equal to slide. And it has a class of window dash slide, blah, 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 blah. Now, this is interesting because we can use this in order to select our slide and find out what its margins are. So let's do that. If we move here into our event listener function, we can declare a new variable. So our variable will be slide equals document.getElementById. And the ID we want to get is slide. So this will allow us to select this, where is it? This slide element. So it will allow us to select it. And now what we're going to do is we're going to get the bounding client rectangle, which to my understanding gets the size of an element and its position relative to the viewport. So in our case, the viewport is this right here. The entire visible part of this web page. So we want to get only this rectangle, and this will return the slide's position relative to the left, the top, the bottom, and the right here. So it will get the distance from the top edge of the viewport, from the left edge of the viewport, from the bottom edge, and from the right edge of the viewport. So let's write this as well. So we're going to create a new variable, slide rect, which is basically the slide rectangle we were getting. And we're going to write slide dot getBoundingClientRect, set of parentheses, and a semicolon. Let's use the console log to see what we're doing here. So I'm going to type in console log, and we are going to log the following elements. First off, we're going to log the left border. So let's type it like this, distance to the left, and we're going to type in slide rect dot left. And then I'm going to copy and paste for all the 4 coordinates. So I'm going to get the distance to the left, distance to the right, distance to the top, and distance to the bottom. So let's copy this, paste it into our JavaScript trigger, and let's see it in action. I'm going to just click on inspect here. So if we bring up the console, you can see all of these distances right here. And you can see that if I resize this, these numbers will change. So the distance, for example, between the slide and the top of the viewport changes. It gets bigger once I resize this. If I bring it back, it gets smaller. So now that we know that, we can just delete all of this. And maybe let's print a message if the mouse is within the bounds of our slide. So I'm going to write an if statement. If the following happens, I'm going to print out this. So the mouse is within the confines of the slide. So what is our condition here? So if the mouse X is greater than slide rect dot left, and I'm going to put down 2 ampersands. So and if the mouse X is smaller than slide rect dot right, and if the mouse Y, so we're going to do the same for the mouse Y, is greater than the top distance and the bottom distance. So this is our condition right here. If the mouse X is between these 2 variables, so between the left and the right, and if the mouse Y is between the top and the bottom, that means we are on our slide object. So we're going to just copy this. And now if I right click here and click on inspect, I can see that nothing prints. You know what? Actually, this is not going to work because I put this check before we declared our mouse X and Y variables. So I'm just going to put it here at the end and save and copy this. And now if I right click and inspect, you can see that if I move the mouse here, nothing happens. But if I move it here, you can see the number of messages that fire with the mouse is within the confines of the slide grows. So I can move it here. But now if I move it here, nothing happens here as well. And even on the rightmost border, so it's still at 624 messages. But now suddenly if I jump here, we have many more messages. We're going to get up to 1000 messages of this type. So this is awesome. Now we know that our mouse is within the slide bounds. This was getting a bit, we have a few lines of code here, so I took the time to comment out each line so we know better what we are doing. So now all we need to do is to adjust our code so that our top corner here will be the 0 for both our X and Y positions. So currently it's at 434 and 66 pixels. We don't want that. We wanted them both to be 0 here. So our satellite only moves while we move the mouse within our slide here. So how do we do that? So I'm going to make some space here and create some new variables, which we will call adjusted x, which will be mouse x minus the leftmost border, so slide rect dot left. And we're going to create also adjusted y, which will be mouse y minus slide rectangle dot top. What we're doing is that we're subtracting from the x position, we're subtracting this distance right here from the edge of the element to the edge of the viewport, and we're also subtracting from the y position, we're subtracting this distance from this top edge to the top of the viewport, so this distance right here. I added a comment so we know what we're doing. I'm going to type in adjusted x equals math. We're going to use the math function and get the maximum between 0 and the minimum between the slide rect dot right and adjusted x. Now I know this can be a lot to process right now, but what this basically does is it takes a value. So this one, the slide rect dot right, and this one, the adjusted x, and it returns the smallest number of the two. This ensures that the adjusted x doesn't exceed the right border of the rectangle. And this part, the math.max, this will help us take the result from this and compare it to 0 and return the largest of the two values. And this will ensure that the x doesn't go beyond the left edge of the rectangle. So I know it can be a lot. As I said, it was a lot of trial and error to get to this point, but I found that this formula works. It's not the only solution, of course. You can implement other solutions if you find them, but this is what I have found to work. I am not a JavaScript programmer, sadly. I'm just experimenting as I go. So we're going to do the same for y. We're going to type in 0, math.minimum, so math.min, open a parentheses, and here we're going to compare it to the slide rect.bottom and adjusted y. So I added a comment. This will ensure that the mouse doesn't go beyond the right and bottom edge of the slide. So far so good. Now all we need to do is to wrap this. So what we wrote here, we need to wrap this in this if statement. So instead of console log here, we will have this code. So I'm just going to copy this, or actually I'm going to cut it into this if statement. So we can make it clearer just by putting these on one line. Let's do it like this. So if this condition is true, which means that if the mouse is moving only within the bounds of the slide, we will do the following, and then we will animate the satellite. Let's copy this. Oops, I made a mistake. I should have changed the mouse X and mouse Y here to adjusted X and adjusted Y in our GSAP animation. And let's also print out the adjusted X and adjusted Y here. This should be good. So this is what our code does. It will get our player here. It will select our satellite object using the accessibility text we set. And then it will, when the timeline starts, it will say, hey, listen for every mouse move. So every time the mouse moves, this function will run, which will first select the slide, find out what its distance from the edge of the viewport is. Then it will store the mouse X and mouse Y position in some variables. And if the mouse is moving only within the confines of the slide, we will then do some operations here. We will adjust the X and the Y so that they are 0, 0 at the top left corner of the screen, of the slide. And then we will ensure that the mouse doesn't go beyond the right and the bottom edge of the slide. And then we will print out these adjusted X and Y values into our storyline text here. And then we will also animate the satellite using GSAP.to. We will set its X to the adjusted X position and its Y to the adjusted Y position. So let's copy all of this and see how it works. So I copied this into my trigger and I'm moving the mouse here and nothing happens. But if I move the mouse to the slide, boom, there we go. So here in the top left, let me just try and, okay, it's 0, 0, but I can't quite get it. There we go. And here, once I move here, the movement stops and then it resumes again once I enter the confines of the slide. So this is it. This is what we wanted from the beginning. You can see that the satellite is close to our mouse now. It follows our mouse around the page. So you can see how amazing this is. What we can do is we can put this object lower. So if you don't want it to follow to be exactly on the mouse cursor, for example, now the top left corner of the satellite box is right on our mouse cursor, we can adjust the number here. We can go -40. Of course, we can create a set of variables here. So var adjustment on the right, adjustment on the left, and we can use them to adjust our mouse cursor. Let's actually do that as well. Let's not actually call it adjustment again because we already have an adjustment here. I'm just going to call it offset on the X equals, let's give it a value of 30 pixels. And here the offset on the right. So I'm sorry, the offset on the Y, offset on the Y. Let's also give it a value of 30 pixels. And here we can say plus offset on the Y, and here plus the offset on the X. And now if we publish this, you can see that the object is a bit lower than my mouse position, both on the X and on the Y axis. If I resize this, the distance increases, I think, a bit. So yeah, the offset, I think it seems greater when the window was smaller. Let me check. So there you go. Yeah, I think it is. Yeah, it's bigger because the slide is smaller. So this is only 410 by 250 to 35, I think. And so 30 pixels is a much larger chunk of the slide. But if I maximize this, the distance is smaller. So there you have it. This is how you move a satellite to follow the mouse around in Storyline.